Hello everyone, welcome back to part 2 of 14.7. So starting off, we have 14.7.043, find the shortest distance D from this point to this plane. So we got a plane, and then we have a point P, and I want to know what is that distance until I touch it. What's that distance D? One thing to note is that it would definitely be orthogonal. In a way, you can say like the slopes here are pointing towards that. So we would use obviously the gradients, the slopes, in order to find that. But let me instead show you a different method that I guess is a little bit more honed in to what we were going to be doing in this section. Basically, we need to find a function that we need to find the min or max for. Basically, we need our distance function, and I propose to you that we use not d but d squared. And the reason why I'm using d squared instead is because it's just easier. Notice that if we had d, we'd have the square root of x squared, y squared, z squared, something similar like that. But if I had d squared, I don't have to have the square root, so when I start taking derivatives, it's much faster. And if you maximize d, then you'll also be maximizing d squared, or similar likewise, etc. So this is going to be my f, just like where I was using in the other problems, f sub x, f sub y. This will be my f now. And again, I'm trying to make this into a maximum, or a minimum, I'm sorry. A minimum. Anyways, so what is that formula now? So I'm going to say x minus the 1 squared plus y minus 0 squared plus z plus 6 squared. Notice that I'm using the point here, and I'm trying to find distance from that point. So essentially, I know this point is fixed, and I want to find the distance from that point down to this thing here. I guess you can call it q, and that would be this x, y, and z here that I don't yet know. Okay, so this for sure was a fixed number. These are variables, which I don't yet know. Well, we have this plane that will help us. Notice if I take these and move it over, I could solve for z. So then I could rewrite this as my x, my y, and then my z would equal 6 minus x minus y, and yet still plus 6. Okay, these 6's will combine to make a 12, etc. Well, we need to find f sub x and f sub y and set them both equal to 0. So we got the 2 comes down, leave this alone, the y goes away. Again, this is a 12, so when I bring the 2 in, I'm just going to say 12 minus x minus y. And then the derivative of the inside of this is going to be a negative 1. Okay, and this whole thing should be equal to 0. Same thing if I'm doing the f sub y. 2 comes down, same thing here. 2 comes down. And then, of course, negative 1, just like last time. Okay. Both of these must be equal to 0 at the same time. And I know there's a lot here that's, similar, but we're going to try to solve for it together. Okay. So, what I'm going to do is just basically write this thing out a little bit better. So distribute the 2. I'm going to distribute the negative and the 2. Same thing here. So I got 2x minus 2 plus, because again, I'm distributing a minus sign in there, right? Negative 24, positive 2x, positive 2y, and this should equal 0. The other one, 2y, get rid of that 0. Again, distribute the minus sign, so it'll be minus 24 plus 2x plus 2y. These guys will combine. These will combine. And these will combine. And so I'm just kind of setting it all up here. So I got 4x plus 2y. And then this will be a negative 26. I'm going to move that to the other side, actually, over here to make a 26. And then over here we got 2x, now 4y. And I'm going to move that 24 to this side. Notice that we have a system of equations. Essentially, you could put this into a calculator and RREF. I know it's been a long time since you've done that. but you would RREF and get the answer. Very fast and easy. The slower way is that you can solve for x and y and plug it back in. I really don't want to go down that route. I just want to make sure that you see that you can do this, because you've done this many times before. Just do it again. You could use calculator, or you can do the manual way of solving for x, plug it in, solve for y, etc. Well, you get x equals 14 over 3, and y equals 11 over 3. With these, you can find your z by plugging those into the plane equation, essentially. This guy right here, I guess you could say z is equal to 6 minus x minus y. I'm plugging that in, and I would get negative 7 over 3. So there's my point Q, I suppose you can say. That's good. If they were asking for that, we would be done, but they want the distance still. And the distance straight up would be the square root. So therefore, 14 over 3 minus the 1 squared, 11 over 3 minus the 0 squared, negative 7 over 3 plus the 6 squared. Notice that I kept that square root because I'm actually wanting the distance, not just the max or minute, but the actual distance. All this in the calculator, or not. I didn't use calculator, actually. It was 11 over the square root of 3. Okay. Cool. Next problem. 147046 says, find the points on the surface of y squared equals 36 plus xz, okay, that are closest to the origin. Notice it says points. There's actually 2 of them. The problem on the homework will have 2 different boxes for you to fill in. And they're talking about smaller and bigger y values. So smaller y value, and then this will be the bigger y value. It's kind of an indicator of kind of where we're going. So let's just go through this problem and see what we can do. Okay, origin is 0, 0, 0. And so if I were to find d or d squared, I mean, really it's just x minus 0 squared, y minus 0 squared, and z minus 0 squared. Obviously, you don't have to write all those zeros. I wanted to show you how I was going about it. That's my f, and again, I'm trying to, minimize closest. Okay. Is there anything else I can do? Yeah, I think I can solve. Well, actually, look at this. This is kind of interesting. So if you rewrite this like this, notice that I have y squared and I have y squared. I literally can plug it in without doing any math, which is handy. And now we have 2 letters, which is useful for finding our partial derivatives. Not that I couldn't do it with 3, but that's just not the formula. The formula is x and a y. So with an x, I got now 2x. The 36 goes away. This guy got a z, and that one goes away, equals 0. Of course, we don't have y's anymore. We're using z's. So f sub z goes away, goes away. Here we got an x, and then we got a 2z. Set that equal to 0 also. So again, both of these have got to be working at the same time. If I take my z and say it's equal to negative 2x, I could plug that in right here. So I got x plus 2 times negative 2x is equal to 0. I got it, that's a negative 4, plus 1 is a negative 3x equals 0. You can see basically x equals 0. And if that's the case, here we got z equals 0. Cool. What about my y? What is y equal to? Well, we had y squared was 36 plus xz, right? So these are both 0. So basically y squared is equal to 36 square root, and so you get y equals plus or minus 6. Remember to have plus and minus, because when you square root both sides, you got to do that. Also, this indicates our answer. We got the smaller y value, which they would want the negative 6, and then the bigger y value, which they'll want the positive 6. And there you go. That was it. 147051 says find the volume of the largest rectangular box, like in 3D basically, in the first octant. There's not a fancy name that I know for that. First octant, with one vertex in the plane, in or on the plane, either way, x plus 2y plus 3z equals 9. Now, if this looks a little bit confusing, I'll tell you what's going on. What they mean by this is this is going to be opposite to the origin. I don't know if they actually said that or not, but that's certainly in my notes. So when I read it, I felt opposite to the origin. So they're going out some x, y, and z, and they're wanting to make a box. Something like that. Okay, so there's my box. I'm basically saying that this guy right here is in some kind of a plane. Let me go ahead and just draw a plane. There you go. So he's touching this plane at one little particular point, and you can see that's the furthest from the origin. I'm trying to say that this point basically creates the box itself, okay? Again, let's just say it's x, y, z, so my volume of the box is simply x times y times z, whatever that is. So that's not too bad. What I want to do is, of course, I want to maximize this. So basically, I'm saying this is my F volume, and I'm trying to find a maximum. Okay. One thing that you can do is I'm going to solve for x by taking these guys to the other side, and then I would plug that in right there. So now I've got 9 minus 2y minus 3z, and then times yz. I also recommend to go ahead and just distribute. That way it'll be easier to do the math in just a second. Okay. So this is my f basically. And so f sub x. Well, actually, we don't have an x anymore, do we? We have a y. So I have 9z. Here I got the 2 is going to come down and make a 4yz. And over here, again, in terms of y, I just get a minus 3z squared. Again, this is equal to 0. F sub z, 9y minus 2y squared. The 2 is going to come down, so minus 6yz. Again, set it equal to 0. We need to figure out what's going on here. I'm trying to see if there's any kind of similarities. Not really. So what I do is I just start solving for z or something. So let's take this bottom here. If I move this over to this side, I would get 6yz equals 9y minus 2y squared. I'm going to divide by the 6y. And so this right here is my z, which I will then plug in right there and right there. And you can see how very large it is. I guess I can cancel a y out there. I'll do that in a minute. Oh, there's another z right there. Look at that. Almost there. Okay. Whew. That's crazy. So one of the things is that we can cancel y's in each of these cases. And I think that'll make it a little bit better looking. That's good. This one here, you're going to want to distribute your 9, distribute this thing, and here you need to FOIL it first. So basically when I toss this in, I got 9 times 9 divided by 6. I simplified it a lot more on my paper, beforehand, and it came out a little bit nicer. So maybe if we were to cancel a 2 everywhere and a y before trying to do all this mess, that might be helpful. I'm just going to go ahead and give you what I got. So I got the 9y, 4/3 y squared. So I'm just simplifying. Minus 27 over 4 plus 3y minus 1/3 y squared equals 0. So that I FOIL this out and then I distributed this thing. Basically, a lot of canceling, stuff combines. Cool, I'm going to keep going. So these guys combine, these guys combine, those guys combine. And so I end up with y squared minus 6y plus 27 over 4 is equal to 0. And then I'm thinking, hey, can I factor that? And so it's not very pretty, but it is possible. So, like, you could technically use a calculator at this point to see what, factors it would be. That might be helpful for you. I often just say, okay, what two numbers will multiply to make this thing happen? And so I know there's quite a variety, but I came up with 9/2 and -3/2. And so then we got y is equal to 3/2, y is equal to 9/2. With these, I'm going to go find my z's now. And my z formula is this guy up here, which I'm going to go ahead and simplify for you, the one that I had on my paper. See, I think that's a lot easier to use. So then my z would be 3/2 minus 1/3 times 3/2. And the 3's are going to cancel. And so I got 1.5 minus 1/2 is equal to 1. Cool. Over here on this side, 3/2 minus 1/3 times 9/2. What you get out of this is actually a negative number. And that's not necessarily wrong inherently, except, actually, no, I don't get a negative. I'm sorry. Back all that up. You get 0. Sorry about that. Okay, so you get 0. Again, negatives or 0, does that even make sense? Well, consider the box that we're making here, right? I'm making a box here in the first octant. If you remember, it did say first octant. So anything over here negative, or even if having a like a width or something of 0, like is literally just going to be a piece of paper, that doesn't give you a maximum volume. So this doesn't work. Again, just thinking about it, negatives won't make sense, 0 won't make sense, but this guy looks good. With these two here, I can go and find my x now. I plug it back in, 9 minus 2 times 3/2 minus 3 times 1, and I get x equals 3. Okay, so there's that. So my total answer here, my volume, again, was x, y, z, right? So I've got now 3, 9/2. No, I'm sorry, 3/2. Sorry. And then a 1, 9/2 total. And there, that's the answer they're looking for. Okay, that's it. Thank you very much. Have a great day.